This GibbsCAM Tech Tip is designed to show you how to use the Hole Manager to machine hole features in 3, 4, and even 5-axis complex parts. This, like all GibbsCAM Tech Tips, is designed to ease your programming tasks, reduce your programming time, and increase your spindle uptime. Let's have a quick look at the part so that we can see what our goals are. We have chamfers, we have counterbores, we have through holes, and even some angled holes here. Let's start by clicking on the solid model, going to the Features menu, and selecting Hole Manager. Inside of the Hole Manager menu, you will find Run AFR. AFR is Automatic Feature Recognition. When you run AFR on a part with holes in it, each hole gets an indicator, and that indicator can tell us exactly what the makeup of that hole is. We will click Auto Group to make it easy for us to select the groups of holes while we are machining. Let's have a look at one of the hole indicators. Click the hole indicator, right-click, select Edit Hole. By selecting Edit Hole, we see the drawing and all of the specs on these holes, including the XYZ location, the type of hole, how many segments it has, and what the diameter and depth of each segment is. This works on all hole features in 3, 4, and 5-axis machines. Now, we don't have any tools. Let's use the new View Edit Tool List function. It's faster and easier than the old Save and Load tools. Now we get to see the tools and preview them before we import them to the part. We can import them individually or all together by clicking Import All to Part. Now that we have our tools in front of us, let's select our spot drill, which is a 5/8 spot drill, and bring it into the process list. Selecting holes, we will select drill, feed in, wrap it out, and get a suitable RPM and feed rate. RPM and feed rate all set. Normally, we would fill out these numbers, but now we want GibbsCAM to do this for us automatically. Let's go to the Hole Feature tab and set our R level from Hole Feature. At op end, same as R level. Top surface Z, top of hole. Feature depth Z, chamfer, and adjust for tool tip. We will select Machining Coordinate System Automatic from Hole Feature. We don't have to add any chamfer amount. Gibbs already knows what the top chamfer of these holes is. Let's go to the Rotate tab and set up for polar and cylindrical milling so that we don't bang into the hub while we're moving from hole to hole. We can select Group 5 and click Do It, and we have now chamfered the top of the holes. We have similar holes on the top of the part that are in Group 6. We don't have to change any parameters anywhere in this menu because now it's fully automatic. We simply click Do It, and now we have chamfered the top holes. Let's have a quick look at that in Machine Sim. Again, we use polar and cylindrical milling. And if we don't like the order in which the holes were machined, we can simply double-click, modify, sort, closest hole next, do it, and redo, and the same with op 2. The sort is always available. Do it and redo, and now the holes are sorted in a more rational manner. It's time to drill the holes through the part on the 280 diameter. Let's grab the 280 drill, a hole making process, switch to PEC full out, get a new feed and speed right off the list, calc RPM, calc feed, and now on the hole feature, we're only going to change feature depth Z to bottom of hole, and we're going to drive the tool minus 50 thousandths through the bottom of the part, and still we're going to be in polar and cylindrical milling. We have group 6 selected, and we click Do It, and the holes are now drilled all the way through the part. The same thing for group 5. We need a new tool. We need a new feed and speed. And then we don't need to change a thing here. All we have to do is click Do It, and we have drilled all the way through the parts. Now it's time to do the counter bores. Let's grab the 5/16 end mill and work on the counter bores using mill bore, helix bore. On the material tab, we will select a suitable surface feet per minute and feed rate, and we now have good numbers. We're ready to go. To the hole feature tab, from hole feature, same as our level, top surface Z, top of hole. Feature depth Z is not going to be bottom of hole. When we select segment end, then we get to select the end of which segment? The 575 bore. Let's go to the bore tab, use circle diameter where available, Z pitch 0.025, start at center, finish at center, and again, cutter radius comp is on so that the operator at the machine can control the diameter of the counter bores. All we have to do is click Do It, and our counter bores are done. The same for the next set of holes here on the top of the part. We're now in group 6. We'll select one of the hole features and select segment end. Let's close the menu and reopen it so that we can reload that hole data. When we go to hole feature, you can see we have a 400-inch diameter upper counter bore. We'll select the upper holes and do it. Now it's time for these holes here on the side. Let's close the menu so that it'll reload the hole data. Click one of the angled holes, and keep note that we do not have to create a coordinate system for this group of holes. There's 3 of them around the outside of the part. Open the process. We already have helix bore feed and speed set. We already have everything set, and we need to select the bottom diameter, the 375-inch bore, and there's going to be no bottom hole adjust. Now we simply select all 3 holes and click Do It, and as you can see, GibbsCAM has machined the helix bores for us, even at an angle that we have no idea where it is. Let's take one more quick look at this part as we go through. Let's reload our simulation so we can see all of our tools. And if we're missing a tool, we can always add one. Drilling through. Let's speed up and go through that. We'll skip that op. Let's skip to the next op, and there is our counterbore machining. Let's skip to the next op. We have more counterbore machining. And let's skip to the final op where we see the counterbores being done at an odd angle. We have no idea what that angle is, but GibbsCAM does. Here you can see that the angle is minus 45 degrees. And the helix bore is obediently going to the right depth. Using the hole manager can speed up your drilling and even your machining. If we wanted to do some machining here on this feature, we don't have to create a coordinate system. We simply right-click and activate CS from hole, and when we go to look at our coordinate system list and home view, we're now looking right down the throat of that hole, and we can perform other machining. Take some time and watch this video again to get used to using the hole manager. You will never want to go back to manual drilling. If you have any questions about this and any other GibbsCAM question, please contact your local GibbsCAM reseller.